Welcome to the product demonstration of 230 volts over and under voltage protection for the high voltage loads. So here we are going to protect this load whenever the voltage is fluctuating from the below low voltage and above high voltage. So whenever the voltage is above 240 volts, so then there will be a chance of this load may get damaged. So for the protection of this purpose, the microcontroller keep on checking the input voltage, and whenever it is above to the 240 volts, then it's showing as a high voltage, then the load will be isolated from the input voltage from that high voltage by using this electromagnetic relay. The same manner for the low voltage also. When it is below 210 volts, then automatically we are going to isolate the same power supply to the load by off this relay. So when the relay got switched off and after the voltage is coming to the normal voltage, then again we need to restart the system, then only the supply will be resumed to the load directly. So here the power flow is 230 volts AC inputs. Parallelly we are providing that AC to the load through this electromagnetic relay and to the transformer. So here the transformer will step down the 230 volts AC to 12 volts AC to this regulator power supply board. So it has 3 stages. One is a rectification purpose, 4 diodes, bridge rectifier. Then after we will get the pulsating 12 volts DC. That will be converted into the smoothing DC with the help of this 1000 microfarad capacitor. So there will get the 12 volts pure DC voltage. So that is input to 7805 regulator. So after that we will get the 5 volts DC voltage. So stages are 12 volts AC to 12 volts pulsating DC and smooth DC, and then regulation after 5 volts. So rectification, filtration, regulation. So the output is given to the main power source to the 28-pin PIC microcontroller motherboard. So on this, so we are the input is voltage variance purpose in real time. So we will get the constant voltage of 230 volts. So for presentation purpose we are varying that. So 0 to 255 volts with the help of this variable resistor. So that is connected to the A0 pin of our PIC 16F72 microcontroller, and that particular voltage will be displayed on the 16:2 LCD screen continuously, which will interface at pin number B2 to pin number B7. And based on these abnormal conditions, we are going to isolate the power supply to the load by controlling this electromagnetic relay. So on this electromagnetic relay we can see the LED which will show the status of the relay, and transistor to trigger the relays directly. So let us see the demonstration. So initially welcome message on the LCD screen, and as of now the voltage is normal condition, that's why the load gets switched on. So whenever it is low voltage, right, so low voltage, and automatically so the bulb will be isolated. When it is coming to normal again, only normal will be displayed on the LCD, but the power supply won't resume to the load, as we need to reset the system again. Because in electrical appliances, for safety purpose, it is not supposed to come to normal whenever it is normal voltage. We need to do reset by manually. And when it is above voltage, again same high voltage alert message, and again when it is normal, reset the system. Right.